Lesson 9.1, Video 5. Now we're going to focus on a rhombus and kites. So, first of all, we have a formula for a rhombus as h times s. Base times height is the formula for the area of a square, but because a rhombus can tilt, you may not always know the height, so they reference it as hs. If you don't know the height, you can just take 1/2 times the product of the two diagonals, and the diagonals being the total length from one corner to the opposite corner. So if you look at a particular example here, we have an example that does in a rhombus that does not have a height. So the formula states that it is going to be using the two diagonals. Problem here, though, is that you have one diagonal, 5 and 5 is 10, but you do not know the other. But if you understand the properties of the diagonals in a rhombus, is that the diagonals bisect each other and they create a right angle. So if we focus on this picture, we create a right triangle with two sides known. So I can go x squared plus 5 squared equals 13 squared. So x squared plus 25 equals 169. If I subtract that from 25 from both sides, I get 144. So x is 12. So if this is 12, so is the other piece, the other half of the diagonal, because they bisect each other. Which allows us then to state that the whole diagonal is 24. So if I take 1/2 times 10 times 24, we get 120. Now let's look at a kite. Notice that the formula for the area of a kite is the same. So what we need is the length of two diagonals. Now we have the length of one diagonal, and that is 80, but we do not know the other. So this is 80. But again, remembering the properties of a kite, it states that the diagonals also bisect each other. So you create, or the diagonals create a right, they are perpendicular to each other, so they create a right angle, and the longer diagonal bisects the shorter diagonal, which would make each one of these 40. Now we're looking for the long diagonal here. So we're going to refer to something we had done just a moment ago, and we're going to focus on this triangle and find out this height. And then we're going to focus on this triangle and focus on this height, or this side. And maybe I shouldn't use h, maybe I'll just use x. And we're going to find those with Pythagorean again. So the first one would have x squared plus 40 squared equals 50 squared. So x squared plus 1600 equals 2500. I subtract 1600 from both sides. Again, this is 2500. I will get 900. I root that and I get 30. So we have 30 from A to the intersection point. Now I need to find the other one, which will give us x squared plus 40 squared gives us 120 squared. So again we have 1600 equals 120 squared, which is 14,400. I subtract 1600 from both sides, and we get 12,800. I root both sides, and we get approximately 113. So, to use our rule, our formula, we need the length, the total length of those two pieces. So 113 plus 30 gives us approximately 143. We take that times 80 and times a half. And that gives us approximately 5,720 centimeters squared. And this ends lesson 9.1, video 5.